Okay, we're back. We're back. Yeah, I'm gonna make this more and more awkward every time. So, here we go. Teaching to an empty room again, 2020. Finally getting to the meat and potatoes of this unit. Today we're doing 5.3, solving exponential equations. So we have graphed them, now we're going to solve them, and we're getting to logs. The logs are coming, we're not quite there yet. So today we're going to be looking at solving equations that have the same base. Okay, so when I say base, when you have a power, like 2 to the power of 2, or if you look at something like 3 to the power of 4, the base is that. Okay, so the base of this one is 2, the base of this one is 3, the exponent is 4, the exponent is 2. Well, what if you start having variables in the exponent? Now, if the base is the same, okay, and there's the base right there, as long as the base is the same, then it follows that, hey, if these two things are equal, then the exponents must be equal, okay? So, in order to solve, we simply equate the exponents if the base is the same, okay? So that's what it says right there. So what we can do is we can take the x minus 5, and we can set it equal to that exponent, like that. And now that's an easy equation to solve, so we'll move an x over to that side, and we'll just get x plus 1, and we'll still have a negative 5 over here. We can subtract 1 from both sides, and we get that x must equal 6. And just for fun, let's check it. So if we go plug it in over here, we would get 2 to the power of negative 6, subtract 5, and that apparently is equal to 2 to the power of, let's see, 2 times negative 6 is negative 12, so negative 12 plus 1. So let's just quickly check. This would give us 2 to the negative 11. This would give us 2 to the negative 11. And everybody's happy because obviously those two things match. They're the same number. Okay, so we're not going to do the check every time, but you're always more than welcome to try. Now we turn to questions like this. So now we have 4 raised to the x minus 1 equaling 8 raised to the 3x plus 5. They don't have the same base right now, but if you can change them to the same base, then we'll be able to solve. So 4 and 8 can be expressed with a base of 2. So I think we're all going to agree that, well, 4 is just the same thing as 2 to the power of 2, and 8 is just 2 to the 3. So instead of writing 8 over here, I could write 2 to the power of 3, and then I still have that exponent, so I'm going to multiply like that. This is still 8. Over here, instead of writing 4, I could go 2 squared times x minus 1, so still in the exponent. Now I have the same base, I can equate exponents. Okay, so same base, equate exponents. So now I just go 2 times x minus 1 equals 3 times 3x plus 5. And, well, this is all hunky-dory. Just distribute into the brackets. So you get 2x minus 2. 3 times 3x is 9x. 3 times 5 is 15. There we go. Subtract 2x from both sides. That's going to give me 7x. Subtract 15 from both sides. I get negative 17. And yeah, that's an ugly one. Divide both sides by 7. And oh boy, that is the magic x value. So negative 17 over 7. That would make these two things the same. Okay? You do not need, on the exam, to do anything further with your answer. You can leave it in fraction form, and you're done. Let's not check this one. It's going to be ugly, just believe me. Okay, try a couple more. Okay, so these are all ones where we have to change the base. I shouldn't say change. We're not changing it. We are rewriting. So we have to rewrite the base on questions like this. So obviously on this one you could probably get it, right? You would say, well, 2 to the power of 5 is 32. But the whole point is, like, if you were doing it algebraically, how would you rewrite 32 as a power, with a base of 2? So you would say, well, 32 is 2 to the power of 5. So in this case, x equals 5. Okay, well, that's easy one. Let's try another one. So here, let's see, not the same base, but 16 can be rewritten as as 2 to the power of 4. So now I can write 2 raised to the 3x minus 6 equals 16, which is 2 to the 4. Okay? Same base, I can equate the exponents. All right, add 6 to both sides. So you get 10, divide by 3. So when x is 10 over 3, those two things are equal. Fascinating. Another. Oh, this one's extra tricky. Oh, I just need a little break here. So a little bit tricky because we've got a lot of things going on here. So we got it equal to 250, which is, you know, scary enough. And what else have we got? We got multiple things happening. Like, you know, what exactly is the base on this side? Well, it's 5 raised to the power of 2x minus 9. So this 2 is just multiplying everything, and that's why those brackets are there. So if that's the case, try to simplify. Okay, another problem I'm experiencing right now is I can't think of a way to write 250 with a base of 5. Not an easy way with a nice integer exponent. But if we divide both sides by 2, then we'd be left with 5 raised to the 2x minus 9 equals, well, 250 divided by 2 is 125. 125 is just 5 to the power of 3. So now I can write 5 to the power of 2x minus 9 equals 5 to the power of 3. So now I have the same base. I can equate the exponents and solve the equation. So add 9 to both sides. So you get 12. Finally, divide by 2, you get a nice integer answer. So x is 6. So plugging in 6 here would satisfy that equation. You knew there would be fractions eventually. So reminder, if you have a over b, if you do the reciprocal, you now have a negative exponent. Okay, so raised to the power of 1. That's the case over here. So I can rewrite this as, well, there's lots of ways to think about it. I guess the question is, like, can I write 81 with a base of 3? And the answer is, yeah, you sure can. 81 is 3 to the power of 4. Okay, 3 to the power of 3 is 27, 3 to the power of 4 is 81. I still don't have the same base, right? Because this is, you could think of that as a base of a third, right? So 1/3 raised to the power of 4 is 1 over 81. That's not quite right yet, so that's why I reminded you about this. So if you do the reciprocal, so if you write this as 3 over 1, which is 3, this becomes negative 4. So now I have the same base, okay? I don't need to write the division by 1. I don't want to confuse anyone, but I just wanted to show you where the 1 went. So 3 to the power of 3x is equal to 3 to the power of negative 4. Well, yeah, now I have the same base, so I can simply equate the exponents. So when is 3x equal to negative 4? I'm just grabbing the exponents. Well, x would have to be negative 4 over 3. Done. That one was especially tricky. All right, some more. The key with these questions is doing lots of practice. Okay, so you'll have lots in your homework book. Just gonna make sure I'm kind of staying here along with my notes. So okay, we got what, 3 more here? 2 on this page. So this one is very similar to the last one. I know that one was tricky. So can you think of a way to write 128 raised to the power with a base of 2? So I do believe that 2 to the 6 is 64. So 2 to the 7, if I double it, is 128. I'm just going to double check my notes. Yeah. So now I would write 1 over 2 to the power of 7. And that equals 2 to the x. Do the reciprocal. So the exponent becomes negative, essentially multiplied by negative 1. Those are all grade 10 rules, by the way. So let me know if you're having issues with those and we can review those. But now I have the same base, and I just equate the exponents, so you just get x equals negative 7. Like, could you have guessed that one? Like, you know, you could have, but the point is, like, do you know how to do it algebraically? So just be careful of just guessing, because I could change this and make it hard enough that you wouldn't be able to guess very quickly. Okay, we've seen ones like this already, but just to do some more. 4 and 8, well, I can write 4 as 2 squared,
and I can write 8 as 2 to the power of 3. So be careful if you have an exponent that is a binomial or bigger, you're going to need brackets around it. So when I rewrite 8, it's 2 to the 3, open a bracket, x minus 1. Over here, 4 is 2 squared. Now I just have an x, so I'm just going to pop it in there, no need for brackets. Now I have the same base, so equate the exponents to solve. I'm going to, well, there we go. Distribute into the brackets, so you get 3x minus 3 equals 2x. Subtract 2x from both sides, that's going to give me x. Now I have 0 on this side, add 3 to both sides, so you get 3. Wonderful, 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 wonderful. Okay, I put this one on a separate page because it's kind of a big one. No. Oh boy, oh boy, oh boy. So we got 2, and boy, that looks like, is that 2x minus 1? Yeah. I don't know how well it came through, but that's 2x minus 1, and that's 27 to the power of x. Well, 27 is 3 to the power of 3. So 3 to the power of 3 times x, so 3 to the 3x. 9 is 3 squared. I have a binomial, so I write 3 squared, open a bracket, rewrite the old exponent there. Got the same base. So here we go, equate the exponents. I'm going to go ahead and distribute that into the brackets. So I get 4x minus 2. Now I'm going to subtract 3x from both sides. Maybe I'll go a touch slower on this one. So that would leave me with 0 on that side. 4x minus 3x is x. Still have the subtract 2. Add 2 to both sides. And you get that x is 2. Wonderful. Well, now we have a whole new level coming up.